Hello, now in this video we are moving on to our learning objective 2. That is going to focus on our first group of the visualization that you are able to use to summarizing the one quantitative data. So one quantitative data, we're going to look at frequency distribution, relative frequency, percent frequency, and the cumulative frequency distribution. Keep in mind we are focusing on the quantitative data. Okay. So what is frequency distribution? So the frequency distribution is a tabular of n data value into k classes, and we call these k classes called the bins. And so based on the value of the data, so the bin limits, so basically for each class, we will have lower and upper limits. So that's the bin limits are cutoff point that define each bin. Bins generally have equal interval width and their limits cannot overlap. And I want to, before we move on to look at how to creating frequency distribution, I want to emphasize the importance of creating this frequency distribution and how to prevent creating an invalid frequency distribution. So in general, for our frequency distribution, we want to make sure for each class, their interval width, or we also call the class width, they are exactly the same, or very close to the same. And the second is for each class, we should not have any overlaps. So should not have any overlaps. So I want to give you an example here. So keep in mind this frequency distribution we are learning here is for the quantitative data. So let's say you collect the data for the customer age, and you notice that the youngest person reply your survey is 16 years old. Okay, and the oldest person filling your survey is 35 years old. Okay, so given this is your data, right? So this is the information you have. So you wanna creating this called bins, right? Or different classes. So the reason we call it bins because on Excel and they do call it bins. So I know on your textbook they are teaching a different method, using the bin to creating the frequency distribution. But in my lecture, I prefer you use another method. So make sure you pay attention on what I'm going to teach you soon. Okay. So anyway. So this is the range 16 to 35. So how can you creating the classes so that they have equal interval and also there is no overlaps? So if that's the case, your first class should look like 16 to 20, 21 to 25, 26 to 30, 31 to 35. Okay, so those are my 4 classes I created. So the way I creating these classes, which is also can be called age group, satisfy these 2 conditions. The interval width are exactly the same, and also there is no overlapping between classes. So why is that? So if you look at for each class, what is my class width or interval width? Okay, some students are going to say, hey, it's 4, 20 minus 16 equal to 4. And so the answer is no. The class width here is 5. So think about 16, 17, 18, 19, 20. So you're actually including 5 age. So therefore, the class width or the interval width is 5, not 4. Okay, so how can you identify the right interval width? You are using the next class upper limit minus the previous class upper limit, like here, 25 minus 20 equal to 5. 30 minus 25 equal to 5. And you also need to double check your lower limit. The next class upper limit minus previous class next class lower limit minus previous class lower limit give you 5. 26 minus 21, 5. 31 minus 26 equal to 5. So if they all equal to the same, 5, 5, 5 here in this scenario, so you all have the same class width, okay, the class width. And then so also we don't have any overlaps, right? So 16 to 20, if somebody is 21, you know they're going to belong to the second class. Okay, so the way I make this frequency distribution classes meet these 2 requirements, the equal interval width and no overlapping on your classes. Okay, it is very important these 2 conditions will be met. Okay, now after you know the success of creating the classes or the basic property of your classes, now we're going to look at how can we creating this frequency distribution. Okay, we're starting from sort the data in the ascending order. So from the smallest value to the largest value. Okay, so when we talk about the basic step here, we're mainly focusing on, hey, you use the hand creating this frequency distribution. But as I said, I'm going to demonstrate using the Excel to creating this frequency distribution for you. So you just need to make sure, so we no longer need to sort in the data because the Excel will sort it for us. But if you use some other software, and so you might need to sort your data before you start to creating frequency distribution. Okay, and then second is choose the number of the bins. And then basically how many classes you want. And we're going to spend some more time to understand, hey, how many classes you should create. So for the class and also for our tests, and I always going to tell you how many classes we're looking for. But in this lecture, we do tell you some methods to determine the number of the classes, just in case when you work on your own data or work on your future job, your boss asks you to determine the number of the classes you should create, right? And number 3 is to set the bin limit. So basically for each class, so set the class limits. What is the lower and upper limit? Okay, and then to look at within each class, how many data are belonging to that class. So basically put the data value in the proper bins, and then we are able to creating this table. So those basic steps is showing you how you are able to manually use your hand creating those frequency distribution, and understanding this also help you to interpreting the data. But again, we are using Excel, will be much faster. Okay, before we look at Excel, like I said, I want to talk more about how to choose the number of the bins. Okay, here is an example. So first, the data set is the PE, price per earning ratio. So if you're a finance student, you might already learn this ratio already. It plays a crucial role for the investor to determine whether the company is overvalued or not, right? So I want to create a frequency distribution for this data set. So first of all, I need to sort the data from the smallest to the largest, right? Like I said, if you are using Excel, don't worry about this step. And the step number 2 is to choose the number of bins. And so we have this called the Sturger's rule. And so on this table, we list all the possible scenarios. If your sample size go to 16, we pick 5 bins, so we need 5 classes. And so if your sample size starts to reach to 32 or above, and then we're going to choose 6 bins. If your class size, sample size starts to reach to 64 or above, and you're going to choose 7 bins. So basically, every time we double the sample size, as you can see, from 16 to 32, from 32 to 64, and we should add on 1 more bin. So the question student is going to ask, hey, I have 35 sample size. Should I use 6 or 7? Again, the 32 is the minimum and the 64 is maximum. So if your sample size between 32 and 64, and we're going to choose 6. If your sample size between 64 and 128, and we will choose 7. Okay, so this is the Sturger's rule. And if you pay attention on your read your textbook, actually all this number 5, 6, 7, 8, 9, 10, 11 is not something made up. So we actually have a formula for allow us to use to actually calculating the number of the bins. So let me write it down so you will know what is that formula to guide us to determine suggest the number of the bins or classes. So the formula to determine the number of the K, so the number of the classes, that is equal to 1 plus 3.3 times log, and then your sample size n. So if you plug in 16 to the value of n here, and you will get the k equal to 5. If you plug in 32 into n here, and you will get the k equal to 6. So that is how these 5, 6, 7, 8, etc. are calculated. So basically use 1 plus 3.3 times log n. Okay, so that is our Sturger's rule. So that is telling us what is the ideal number of the sample size we should pick. Okay, so after that, we need to set a lower and upper limit of our classes, and then based on that classes that we set up, and trying to determine how many values should be within the classes. So for instance, in this the example, the PE ratio, we decided the classes width double check, right? 20 minus 10 equal to 10, 10 minus 0 equal to 10. So the class width is 10, and we totally have 1, 2, 3, 4, 5, 6 classes. And so how can we figure out the frequency, this second column, right? So we determine the classes. So the frequency means how many original observations belonging to each classes. So for instance, if we go back to look at how many original observations between 0 and the 10, and if you look at this, we found a 7 and a 9. So we did not including the 10 in that upper limit. So therefore, we came back here, to put 2 here, okay? And then the second class, we are including the 10, not including the 20. So how many observations is between 10 to 20? So the answer is 24. We can go back to original data. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, and 24. Like I said, including the lower limit 10, but not including the upper limit 20. So therefore, that is how this 24 are identified. So basically, to look at the original data, how many are between the how many raw data has the value between larger than equal to 10, but smaller than 20. So we are doing the same thing for the rest. So one thing I want to call out for our frequency distribution, if you're adding all your frequency distribution together, you will get this number here. So this number is your sample size. Okay, so why I need to emphasize that? Because if you're creating frequency distribution, if you're adding all your frequency together, if you don't get your sample size, that means when you're creating frequency distribution, you are missing some original raw data. Okay, so if you're adding all your frequency together for each class, the end here has to equal to your sample size. Okay, so this is called a frequency distribution. Basically, look at how many raw data are belonging to each class. Okay, so the next is called a relative frequency distribution. So relative frequency distribution means we are using each frequency.